from 1 to 2, 1 including, 2 not including, I always have the output y equal to 1. But next, from 0 to 1, I always have y equal to 0. X from negative 1 to 0, I always have y equal to negative 1. X from negative 2 to negative 1, I always have y equal to negative 2. This is negative 1, negative 2, negative 3, so forth and so on. And the function, you guys see why we call it step function. Keep stepping up. Okay? And of course, not stop right here, keep going up, keep going down forever. Okay. Now, we have the graph. We understand the properties of this function. Let's take a look at the graph and we find the domain and the range. Okay. Let's start with the domain. Domain is all real numbers. Why? Because we technically can plug in anything in a graph, right? We have no restriction. We can plug in x equal to 1, 2, 3, 1.1, 1.2. You can plug in x equal fraction, rational number, irrational number, any kind of numbers. Okay, so all real numbers. Now the tricky part. What about the range? See what? The range is just integers. Right? All integers. Okay, because we cannot have decimal or fraction as the outputs. Right? We only have the whole numbers, integers. Right? Dot, 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 negative 2, negative 1, 0, 1, 2. Okay? This is going to be your range, all integers. Okay? Is that increasing or decreasing? I cannot say it's increasing because in here, when you, according to our definition, okay, when you increase in the x value, x is 1.1 to x 1.2, you got the same y. Y is not getting bigger. But all I can say is what? This is a non-decreasing function. Decreasing. Okay? It's not going down. That's all I can tell you. What I cannot say is it's going up because it's been flat sometimes, it's going up some other time. Okay? Any kind of symmetry? No symmetry. No max, no mean. Okay? And we call it the step function. Okay, and those are all about section 3.4. So you guys see that with this section, what we learned is show you some typical function, introduce you some typical function, and you guys are going to see some basic properties of it. Okay? And let me move on to the next section, sections 3.5, and I'm going to show you some important techniques that help you to learn math, learn algebra later. And I claim that the technique I'm about to show you in 3.5 is going to be very helpful. It's help you not just for this course, you're going to use it in pre-calculus and then calculus as well. Okay? So pay attention to this and see how it turns out. Section 3.5. Let's talk about graph transformation. Okay, so pretty much in here we have a graph, and what we're going to do is we're going to shift the graph around. We're going to move the graph up and down and left and right. We can even flip the graph over the x-axis, flip the graph over the y-axis. We can even deform the graph with stretches or compresses horizontally or vertically. Okay, and I'm going to show you all of those at once. So to make it easy, let me just start with an example, and then I'm going to work on the example. Example, okay? F of x equal to, just make up x squared plus 4x minus 3. And here, just an example. You can work with any kind of function. Even more than that, let me extend the concept a little bit more. Let me write it this way. We call that f of x equal to x squared plus 4. It's the same thing of writing what y equal to x squared plus 4x minus 3. Okay? Our book write this way, but I strongly encourage you guys to write y and x. It looks simpler, and it's going to be more powerful. Because later on, when you guys move on to pre-calc, you may not work with function. Maybe any general equation, any equation in general. And this technique still works, okay? So I strongly encourage you guys to work with this form right here. So instead of write f of x, a function form, you can write this way, okay? And if I write this way, it's going to be a little bit different from the way the book writes, but I claim the idea is exactly the same. If you read the book, you can compare and see. All right? And the way I explain to you is going to be a little bit deeper than the book, and hopefully that will help you to understand this a little bit deeper, and you can carry it over to the next course. Okay, so we have a function, and I rewrite it as an equation in general. The first type of transformation we're going to learn is shifting up and down. Shifting up and down. Just go down, WN, right? Okay. So you see in here is a parabola. The parabola is a parabola. Okay. So our job is to shift the parabola up and down. Go up and down. How do we shift the parabola up and down? You know that whenever you move something up and down, you are changing the y value. Okay. You're changing the y value up and down. See, change the y value. You move left and right, you're going to change the f. Up and down, change the y. So how do you change the y value to move up and down? So you got the original function right here, right? Say you want to move up 5 units. Again, 5 is just an example. Right? You move up 6 units, 7 units. You do the same way. Just change 5 to the other numbers. Okay? You move up 5 units. This is what you need to do. You change y to y minus 5. All right? That's what I'm going to say. So my original equation is this. Original equation, I don't need this anymore. Original equation is y equal to x squared plus 4x minus 3. What I need to do is whenever I see a letter y, I will change to y minus 5. So the new equation is going to be, this is the original one. Original. The new equation is this. Y minus 5 equal to x squared plus 4x minus 3. You see what I've done? Whenever I see the y, I change to y minus 5. Okay? And this equation, this new function, gonna be 5 units above the original. So if you have the original graph right here, the new graph gonna be up here. And how far is it? It's 5 units away. That's what it's saying. And our book's gonna omit this step. It shows you what? Add 5 on the other side. Okay? Which is pretty much the same. However, it only works for function. And I'll show you right here. You can work on anything. So here you add 5 on both sides. You got what? Y is equal to x squared plus 4x minus 3, and then plus 5, right? And you simplify. This is how our book shows you. Say what? Add 5 to the end. Go up 5 units. It seems easy for now, but it's not really general like that. Really, you change y to y minus 5. Just go up 5 units. Okay? So if you know how to move up, move down, you go the opposite direction, you change the sign. Say you want to go down 3 units. And you hit to change y to y plus 3. The whole thing gonna go down 3 units. Original function, so the same right here. Alright, this is our original function. Move down 3, you change y to y plus 3. So the new function gonna be, a new equation in general gonna be y plus 3 equal to x squared plus 4x minus 3. Okay? But our book gonna skip this step. We're gonna write this way. Y equal to x squared plus 4x minus 3, and then subtract 3 at the end. They subtract 3 on both sides. Make it looks like one function solving for y only. That's okay. That's good for now. But I claim that this is going to be more powerful. You stick with this first before you change. Okay. Now you know how to shift up and down. Let's talk about shifting left and right. Okay. You know that for up and down, you're changing the y value. So by similarity, if you move left and right, you are changing the x value. Okay. So the original function is right here. You want to shift it to the right, move it to the right, or you're going to move it to the left. Okay. You change the x value. And same idea. Say I want to move right. For example, 4 units. This is my 4 units. What do I need to change? I need to change x. Now I move left and right, I gotta change x. Move to the right, guess what? I change x to x minus 4. Just like moving up, right? Same direction. For positive direction, you do y minus, right? For the y, and then what? For the x direction, you do the same thing. Move x to the right 4 units, you change x to x minus 4. So if I have the original function is this, but the new function, same idea. Whenever you see a letter x, you're gonna change it to x minus 4. So the new function is this: y equal to x minus 4 squared plus 4 times x minus 4, and then minus 3. Let's see what happened to the original function. Whenever I see a letter x, I'll change to x minus 4, and I have the new function. Okay? And this one is the same function as the original one, except it is 4 units to the right of the original one. Same shape. Okay? Similarly, if you want to move left, you do the same thing. Instead of subtracting, you do adding. Move left, say 2 units. All you have to do is you change x to x plus 2. Okay? My new function is this. I can cheat a little, right? X plus 2, x plus 2. You have to change all x to x plus 2. Okay? As you shift it left and right, second item. Let me move on. Number 3. I'll be talking about reflection. Number 3, reflection. In here, I'm going to flip the graph over the x-axis over the y-axis. So graphically, let me show you. So I got the graph right here. If I flip it over the x-axis, I'm going to have the graph like this. Okay, flip over the x. I got to draw it a little bit lower. Okay. All right. Flip the graph over the x-axis, you have this. And if you flip over the y-axis, you're going to see something like this. Okay? Flip that one over the y-axis, you have this. Flip over the x-axis, you have this. So I'm going to show you how to flip the graph over the axes, okay, x and y. So graphically, say you have a graph like this. You want to flip over the x-axis, you have something upside down like this. So what do we need to change to flip over the x-axis? We are changing y to negative y. Okay? Okay. So first of all, reflecting. I want to say like flipping. It's like more informal, but that's easier. Reflecting about the x-axis. What you need to change? You change y to negative y. Y to negative y. Okay. So, if I have a function, original function is this. Okay? I want to flip that function about the x-axis. I want to change y to negative y. So my new function is going to be negative y equal to x squared plus 4x minus 3. All right? And this is the step that I really want to emphasize. I want you guys to know. Our book, skip that, omit that, and move on to the next step. Multiply or divide both sides by negative 1, so they solve for y right away. Okay? So you got y is equal to negative of x squared plus 4x minus 3 in parentheses. Right? Multiply both sides by negative 1. Or y is equal to negative x squared minus 4x plus 3. You see the answer. But really, this is the original step that I keep emphasizing all over. Whenever you want to flip over the x-axis, this is my column, okay? What you do, you change y to negative y. That's the key. Similarly, you want to reflect about the y-axis. What you need to change now, you change x to negative x. All right? So you have a graph like this, okay? You flip over the y-axis, it's going to be this way. This, look at this, okay? the new equation is going to be this. Y is equal to negative x squared plus 4 times negative x minus 3. Okay. So what you do is you change x to negative x whenever you see an x. And of course, if you simplify, it's going to be x squared minus 4x minus 3. Yes, I leave the simplification for you guys to do it because it's algebra. You guys can do it by yourself. The main point is the change that we make to flip or to deform a function. Okay. Let's move on. Now we talk about more tricky part on transformation of the graph. We're gonna compress or stretch the graph. So 2 ways again. We can compress or stretch vertically, or we can compress or stretch horizontally. So far we haven't changed the shape of the graph. It looks exact same shape. It just move up, move down. It's just upside down or left to right, right to left. But now we're gonna make the graph look skinnier or look fatter. Okay. So number 4, compressing or stretching a graph. Okay. First, we talk about compressing or stretching what vertically, up and down. Okay. First, compressing vertically. Another word, you compress vertically. Say the graph is this tall, right? You press it down like half of the height or something. Okay. Say compress it vertically, say by a factor. Of 2. By a factor of 2, compress by a factor of 2 means what? You shrink it down so that the height is cut in half. So let me draw the graph first, and then I'll explain this to you. The graph looks like this. X is 0, y is negative 3. So it's going to be somehow like, I think it's like this. Okay. Let's draw another graph. It's easier, like a man or something. By factor of 2. I need some room. Okay, this one is big enough. Okay, so you have a graph. Okay? And you compress the graph by a factor of 2 means what? This is your ground right here, the x-axis. Okay? X-axis is your ground. And you work at one point at a time. Say this point right here. How tall is it from the x-axis? This tall, right? Okay? That is the height of this point. You cut it in half. This point is going to move down to this point right here. It's halfway. Similarly, this point right here. Okay, it's that height from the x-axis. It's going to be right here. So this point will go down to this point. And if the point is below the x-axis, say this point right here, this is the height, the depth of the x-axis. Cut it in half. It's going to be right here. Okay. And of course, if the point right on the x-axis already is going to be right there, because half of 0 is 0. Okay. So if you have any point, say the point right here. Okay. Half of that point is going to be right there, right in the middle. Okay. And of course, if you connect all the middle points, so this point right here is going to be half. You're going to have a new graph that looks like this. I have to draw it better. Okay. So the graph is kind of fatter because you shrink it down. And then the next question is, what do you need to do to compress a function of graph by a factor of 2? Of course, when you do vertically, you have to change the y value. This is what you're going to do. You're going to change y to, see what? 2y, okay? Recall what we do with up and down. You go up, you take y minus something, right? You go down, add something. You compress, the opposite of division, multiplication. You multiply by 2. And the new y is going to be a half of the original one. Okay. So, the original function, say you got y equal to x squared plus 4x minus 3. The new equation gonna be this: 2y equal to x squared plus 4x minus 3. And again, this is the step that I want you guys to see. In our book, they're going to omit this step. Instead, they're going to divide by 2 for you right away. So if you divide by 2 on both sides, you got y is equal to 1/2 of x squared plus 4x minus 3. It's good to know this one, but it's better if you know the intermediate step that show you how to get to the final answer that our textbook show you. Because I claim that you don't stop at college algebra. Later on, you guys are going to move on to the higher course. So this one is important. Okay, so by similarity, if you want to stress instead, compressing, now stretching, vertically, say by a factor of 3, what do you change? You change y again because vertically you change y, right? Now you stretch, you make it 3 times taller, okay? Change y to y over 3, right? Then the graph gonna be stretched vertically by a factor of 3, okay? New one is what? Y over 3 is equal to x squared plus 4x minus 3. One more time, you won't see it in the books. Instead, you're gonna multiply both sides by 3 for you. So you got y is equal to 3 times of x squared plus 4x minus 3, all right? Okay, now if you learn about vertical, it's going to be the same way for horizontal changing. If I'm going to compress horizontally by a factor of 3. So I compress vertically by a factor of 3. What do? I make it look skinnier, right? So try to explain it to you. I have a function like this. Okay, now I'm gonna compress by a factor of 3. Means what? Any point on the graph, this is how far it is from the y-axis. I'm gonna make it 3 times closer to the y-axis. So this point right here is gonna move all the way to this point. Okay, so this point right here is gonna move all the way to this point 3 times closer. Say this point right here, this point right here, right, is gonna be right here. Move 3 times closer. Of course, the point on the y-axis is going to stay the same. And then if I got a point right here, we're going to move 3 times closer. It's going to be right here. Any point on the graph is going to be 3 times closer to the y-axis. So you have a new point. And of course, your new graph is going to be like this. Okay. Every single point on the original graph will be 3 times closer to the y-axis compared to the original ones. Okay, so what you're gonna change is x to compress, right? So 3x is gonna move closer. My original is y equal to x squared plus 4x minus 3. The new one gonna be this: y is equal to 3x squared plus 4 times 3x. And then minus 3. You see what I've done? Whenever I see a letter x, I'll change to 3x. Okay, of course you go ahead and simplify. Then you have the answer. This one is going to be y equal to 9x squared plus 12x minus 3. And 3 squared is 9. Okay, but I'll leave the algebra part for you guys to do. I'll just show you the technique. Okay, last thing. Instead of compressing, you can do stretch. Horizontally by a factor of, say, 4. Okay. Then you're going to change x to what? X over 4. And stretching is the opposite of compressing, right? So the point right here is going to be 4 times further away from the y-axis. You're going to have more wide open drop. Okay, so the original function is the same. The new one going to be this: y is equal to x over 4 squared plus 4 times x over 4, and then minus 3, okay? And then if you want to simplify, it's going to be x squared over 16 plus x minus 3. Usually I'll stop right here because you guys can see the transformation that we've done, but you want to simplify. And last thing before I graph up our video clip for this section 3.5, you can do multiple transformations, okay, just one at a time, and you can get to a new graph. Let me show you. One more example, and then we stop. Okay, easy one. Y is equal to x squared, the one that we learned on 3.4. Your graph of this is proper, also the x-axis, right? So y equal to